Next, we have Jason Goodman from Cray. This is a bio that is just, you know. No, it's straight on. It's totally like. This is one sentence. I mean, you know, that rocks. This is my opportunity to say, hey, thanks to Cray. You've heard me say it before, and I will say it again. We cannot make this conference happen without vendor sponsorship. He said, leaning into the microphone that's not even on. You know, oh yeah. So thank you, and thank Cray. Let's a round of applause for Cray for sponsoring this, sponsoring OpenSFS. Thank you. Jason Goodman is the senior, and here it says PMMSDM at Cray Incorporated. One of those M's must be marketing. Partly Magic Maven, super data molybdenum at Cray Incorporated. Let's hear it for him.
Thank you. Thank you.
Out the acronym.
All right. Thank you, Steve. I'm not going to talk much about OpenSFS yesterday. Charlie did a great job with that. And I just really appreciate the Wizard of Oz metaphor. And in my mind, the whole time, you know, the wizard, the man behind the curtain was you, Steve. You know, we're just going to pull that curtain back, and there you are, OpenSFS.
With great power comes great responsibility.
All right, so look, what I'm going to talk about is just a little bit about Cray. Many of you know us, but we constantly go to shows and get questions. Cray, you mean like Cray, or Cray Research, Seymour Cray? Yeah, so Seymour Cray, the original founder, started this thing called Cray Research in '72, and we're continuing on. There was a stint, you know, where assets were acquired by SGI, then reacquired by a company called Terra, back to Cray. So we're at Cray Inc. now. We're a public company, and we're doing pretty well. You know, last year we did $725 million. We've got a good goal for $825 this next year, and a lot of work to do to get that. And another interesting facet is that we're global. We're really building out our organization. So if you look at it, you know, from a earthly point of view, it's not just North America. We've got salespeople here from all over the world, Asia Pacific. Jag is here from India. He just started with us. And we recently opened an office that's the headquarters of Europe in Bristol, UK. So a lot going on there. And just, you know, in terms of where we are as a business, there's really two facets or two sides to it. One is this world of traditional supercomputing, which does drag a lot of storage for us. And there's this other world of big data, which is relevant both to commercial companies as well as, you know, nonprofit and other organizations. And what's really fascinating from the storage side of things is that the big data chunk is really big. And instead of buying a little bit of storage with a supercomputer, suddenly a big part of what analytics jobs are doing is really all about storage. So this is a Pete Ungaro slide. This is, you know, our big vision for the world. It's really this world of supercomputing coming together with big data and analytics. And the scientific models and analytic models share this common thread of data-intensive computing. In other words, we're driving more speeds and feeds. It's all about big and fast data. And this is really where Cray is focused. So we have three different lines to our business. It's not just computers. It's also storage in the middle, which I'm going to talk a little bit about in tiering, and analytics, both graph and the Hadoop world of analytics. And then although we address, like, so for example, in analytics, we've got a Major League Baseball customer, you know, but still a good chunk of our business comes from national labs, government agencies, and these verticals along the bottom. The one on the far left, Earth Science, is one of the biggest, but then we're really doing well in other ones like, you know, oil and gas, life sciences, and new to financial services, but a lot happening there as well. So one of the recent things that we talked to the investment community about is huge projects that we're working on delivering, like Trinity with Los Alamos, the Coral project in partnership with Intel and others, which is happening, and a system that's already out there, a really amazing system in the oil and gas world, is PGS. So for example, I think last year I mentioned Trinity up top, but it's unprecedented in terms of the amount of data on Lustre, and also unprecedented in terms of what we're trying to do with flash storage inside that huge XE40 system at Trinity for things like checkpoint restart. So weather is one example where over the last couple of years, we've just done really well, both on the compute side of things, where the models that they've got to process within these finite time frames, mission critical time frames, are exceptionally data intensive. So the majority of these tier 1 and tier 2 wins that we have actually have Cray storage solutions behind them as well. And one of the interesting things, if you go to cray.com, there's a link on the homepage to the Today Show. So they did an interesting skit talking about the weather and the models and how there is this little, friendly competition, I'd say it is, between the European outfits and the US outfits like NOAA. So if you got time, check it out. It's on cray.com. So tiering. A lot of us in the room know about, with Lustre 2.5, we had these great capabilities to plumb into Lustre to do things like HSM off the back. And we've built, we've built a product really around that. So on the very far right, we have this thing called Cray Tiered Adaptive Storage, or TAS, which lets you connect into any Lustre 2.5 system or later, and effectively then be a landing point for Lustre to archive the data off of it onto disk or to tape, but then also to stage it back up in. And we sell a product called Synexion, which is our Lustre appliance system, but this TAS on the far right will work with any Lustre 2.5 system or greater. And then on the far left, we have Cray Data Warp, which is our solution for cache acceleration. Oh, this is not, wait, it's not, can't really see there's supposed to be descriptions under each, but you can't see them. So on the far left, Cray Data Warp is all about I/O acceleration, and it's a blade-based, it's a hardware-software integrated system that comes as an option with any XE series system out there, the XE30, the XE40, and future XE systems. And effectively what that does is provide you with a way to take advantage of the latest SSD NVM technologies out there and offer effectively a tier 0 to speed up I/O for various applications that need it. I mean, we've heard all sorts of talks today and this week about, well, Lustre doesn't fit everywhere. There's some I/O models and I/O-intensive apps that just simply are not well suited to Lustre, and this is where we can offload that I/O from the underlying Lustre file system into the supercomputer. So I wanted just to talk a little bit about the reality and myth behind the data lifecycle. In other words, when you initially create a project or data or acquire it somehow, it's typically all about speeds and feeds and processing and analyzing that data rapidly. So on this vertical axis, you see throughput. It really represents throughput and IOPS. And over time, it's more about, it becomes less and less about throughput and IOPS and more about persistence and holding that data cost effectively. So in an ideal world, you could do your work rapidly when you need to, and then move the data off to more cost-efficient long-term storage, whether it's disk, tape, object storage, cloud, or whatnot, and then never touch it again. But the reality is, especially with these new models for analytics, is that there is this long tail effect in data management, where some researcher, somebody wants to go get data from a project they created 2, 5, 10 years ago. It may be only a few files, but they've got to have access to that data. So one of the things that we try to do at Cray is to maintain data accessibility throughout this lifespan of the data. So on the far right, you can really store data efficiently long-term on tape, and it's hard to beat that. But also, you need to be able to get that data off of the tape. So there's really two models for this. You can imagine, so in the very middle, we happen to say it's Cray Synexion. This could be any Lustre 2.5 file system or later. And the idea is this, for a lot of HPC, this offers this persistent namespace. And with TAS, we give you then a way to get the data off of Lustre and back onto Lustre through policies that look pretty much just like SAM QFS, for those that are familiar with Sun, SAM, FS. And the underlying file system on TAS is from Versity, which is the open source version of SAM FS that works on all Linux. So effectively, it's an all Linux-based system. The policies are familiar to a lot of people, where it could be based on age of file, file types, who's using the data, and so forth. So that's pretty straightforward. When the data is living in Lustre in the middle, we then need a way to get it up into the supercomputer such that when a job is ready to go, the data is staged and ready to be processed. So what's really cool about data warp is not just the ability to do stuff faster, it's the data management capabilities that come into it. So in other words, through a job script or a workload manager like Slurm, you can go to kick off a job, but the job won't start until data warp has staged the data up from Lustre into what looks like another file system, /SSD. It's managed by data warp, and then it automatically provisions all the storage. So that storage, so one scenario is it's just to one node. It's like node local scratch space or temp space. But another scenario might be it's globally available to a set of applications. Then when all that is automatically provisioned and the data is staged up into that file system, the job is kicked off. There's, and the customers are finding, pretty good numbers in terms of performance, in terms of how fast things can go. Kaust, NERSC, Trinity, we've got about 5 or 6 people using this right now. And when the job is done, what's really neat too is that the results, the intermediate data, can then be staged out or trickled back down to that one Lustre file system or to another. And then all of the other storage configuration setup either destroyed or kept or whatnot. So it provides a really flexible model for getting data in and out of the supercomputer today. So with that, that's pretty much it. We're really glad to be here. It's going to be, I'm curious to see what's going to be happening with OpenSFS. We're excited. We're doing a lot with Lustre and our partners around this, and we're just excited to be here. So with that, I will open it up. I will open the curtain.
Thank
you, sir. Or your mic, there you go.
Thanks so much. Hughes? Lines for those of you that aren't British? No, sorry. Free association. Maybe it's just cheap association. All right. Thanks, Jason.
Okay.